Hey, welcome to a new chapter, chapter 9, rational functions. And we're going to start here where we start with a lot of units, and that's actually looking at the transformations. Feels like we're doing this over and over and over again. But before we do that, we need to go back to 20-1 and look at some of the things you did there. So we did one section on reciprocal functions in 20-1, and now we're going to build a lot more on that. So it says fill in the table for the function y equals 1 over x, then draw the graph. And this is a reciprocal function. We've got the x in the denominator. So I've got some different values I want to substitute in and then draw the graph. So 1 divided by negative 2 is negative 0.5. Negative 1 divided by negative 1 is negative 1. 1 divided by negative 0.5 is negative 2. Then we get negative 4. Now 1 divided by 0, we can't do that, so we're just going to leave that blank. 1 divided by 0.25 is 4. And then 1 divided by 0.5 is 2. Then we get 1 and we get 0.5. So now we're going to go plot those points. So at negative 2, we get negative 0.5. At negative 1, we get negative 1. At negative 0.5, we get negative 2. And then at negative 0.25, you get negative 4. Now this graph is going to approach the y-axis, but it will never actually hit. There's an asymptote there. Same for the x-axis. It'll approach the x-axis, but it will never hit. In the positive direction then, so at 0.25 we have 4, and at 0.5 we have 2, at 1 we have 1, and then at 2 we have 0.5. It's going to be the same thing here. You have an asymptote at the x and y axis, so these graphs will actually never touch. And now looking at our domain. So x cannot be 0, but it can be any other number. So x such that x cannot be 0, where x is a real number. And then for our range, it's actually the same thing. So it's y such that y cannot be 0, and y is a real number. So then where do we go from here then? So we've got sketch the reciprocal of the linear function y equals 1 over x minus 5, and then to determine the domain, the range, and then any asymptotes. So first off, this x minus 5, it's already been graphed for you actually. It's right here. So we can see our y-intercept is negative 5. It's a slope of 1. And then now, we can look at this another way as well. It's been shifted over 5 to the right from y equals x. So now we want to reciprocate it. So any places where it hits the x-intercept is going to create an asymptote. So right here, it's going to be an asymptote. And that's going to occur at x equals 5. So we can already put that in our asymptote equations. And then our next part is, we'll do the invariant points. So 1 over 1 is still 1. So anywhere our height is 1 or negative 1, it's going to stay the same. So we've got a spot there. Do that in a different color for you. So we've got a spot right there and a spot right there where the height is either 1 or negative 1. From here, we have to start reciprocating. So going to the right, the value of our graph is getting bigger and bigger, which means when you reciprocate it, it's going to get smaller and smaller as that value gets bigger. Because when you divide by a really big number, you're going to get a small number. Now the opposite is true here. As the graph goes to the left, it actually starts approaching 0. And when you divide by a small number, your number is going to get bigger and bigger. And keep on going. Now from this invariant point, same thing. To the right, we're getting smaller, our original graph. So our reciprocal is going to get bigger. And then to the left, our value is getting bigger, so we're going to go low then. So now we can do the domain and range of this. So if I look at my original y equals f of x, we can see our domain would be, well, it can be any x value. So x such that it's a real number. And then our range is the same thing. So y such that it is a real number. Now for our reciprocated graph, it's very similar, except for we have that one point that's an asymptote, or one value, and that happens when x is 5. So therefore our domain is x such that x cannot equal 5, but otherwise x is a real number. As for our range, if x was to be 5, like that would be the location where you would get 0, but we can't divide by 0, so therefore y cannot equal 0 then, where y is a real number. we've already written in that one asymptote equation. So our next question looks really similar. Still same thing, still sketch our linear function. But this time it looks like we've got a couple different transformations that could be happening here. So the graph -1/2 x plus 2 has already been graphed for you. And we want to do the reciprocal. So again, where it crosses the x-axis, that's going to be my asymptote. So right here. And that's going to happen at 4, where x is equal to 4. Now if we look at our equation, actually, that's a bit of a problem because we have 2 and -1/2. You would think it would be 4, but you might be forgetting this -1/2 can't be right next to this x when we're looking at transformations. We need to factor that out. So then it's going to actually be x minus 4. And that makes more sense. If our asymptote got shifted 4 to the right, yeah, that makes sense. Then we start looking for invariant points. So any height of 1 or -1, so we've got 1 there and then -1 there. And then we just kind of look what happens to the graph. So as we're going to the right, our original is getting bigger, so the reciprocal is going to get smaller. And to the left, the original is getting smaller, so our reciprocal is going to get bigger. To the right here, we're getting smaller, so our reciprocal is going to get bigger. And to the left, our original is getting bigger, so we're going to get smaller. Now, if we just take a second to look at the transformations that have happened here, our asymptote has been shifted 4 to the right, so that matches our equation. Now our b value is -1/2, which means this should have been horizontally stretched by a factor of 2 and also reflected. Now has that happened? If we go back to our other graph, we can see that it was actually on the other side of the asymptote now. So yes, it's been reflected, and it looks just a little bit stretched out compared to this one. Maybe if you were to zoom out a little bit, it'd be more obvious. Okay, let's do our domain and range then. So this is of our original f of x. So it's a linear graph. It's just going to be all real numbers. So x such that x is a real number. And a range will be the same thing. So y such that y is a real number. Now for our reciprocal, really the only thing that matters is this asymptote at x equals 4 and y equals 0. So we can't have values there. So our domain of our reciprocal is going to be very similar, just can't have that 4 value. But it's still real numbers. And then our range, so y such that y cannot equal 0, but it's still in the real number system. And our asymptote was at x equals 4. Now in 20-1, as you move through the course, you started doing parabolas and taking the reciprocal of those as well. So we're going to graph this equation y equals x squared minus 4 and then draw the reciprocal of the function on the same graph. So here if we look at this, it's in vertex form. So we can say our vertex is at 0, -4. So we can go and graph that right now. So 0, -4. And our other important point is going to be, because this is luckily on the y-intercept, we want our x-intercepts. So we'll do x int, and we're going to have y equaling 0. So 0 equals x squared minus 4. Add 4 to both sides and square root. So you get plus or minus 2 equals x. So therefore we have 2 points. They are at 2, 0 and -2, 0. So we go and plot those points. So 2, 0, -2, 0. And we have our parabola. Now another key point, if I want to be really accurate, would be my invariant points. And that's where our height is equal to 1. We're not going to get a nice number here anyway. You're going to get square root of 5. It's not going to help us too much. I'm still going to be kind of estimating where that would be. And that's for my reciprocal. So next I'll draw my asymptotes, and those occur where I cross the x-axis. So that one is going to be at x equals 2. And our other one is going to be at x equals -2. Okay, now that we have those, we're going to go look for our invariant points. So again, that's the height of 1. So here mine's a little bit hard to see. It's pretty close to that asymptote. Here it's a little farther out. And then also don't forget the negative ones as well. So -1, -1. Now, if this was perfectly symmetrical and a lot more points on here, it might be a bit more accurate. We're just going to sketch this though. So if we're looking at the trend of this graph to the right from this invariant point right here, this graph is getting bigger, so that means our reciprocal function is going to get smaller. As it goes to the left, it's going to get bigger because our original graph is getting smaller. On the far left, we have the same thing happening. From this invariant point, as we go to the left, our original gets bigger, and as we go to the right and approach the asymptote, it gets smaller. Now down here, it's a little bit different. So below the x-axis, my -4 is going to get reciprocated. So this point is going to become 0, -1/4. So that's going to be approximately here. So I'll label that 0, -0.25. So these points will kind of connect. And then as from our left invariant point, as we approach the asymptote, the original, it gets very small. So then our graph is going to get very big, our reciprocal, and it's going to look similar on the right side of that as well. Now I just want to look at 3 more quick questions from Math 20-1. So these just say, draw the reciprocal of the quadratic function below. The quadratic's already been drawn for you. So all we're really looking for then is our asymptotes and our invariant points. So for A, we have one right, looks like it crosses at the origin. So there's our asymptote. And we have that happens at x equals 0. Looking for our invariant points. So it happens at a height of 1, height of 1. And now we're going to just sketch the trend. So to the right from this invariant point, our original gets very big, so we're going to go low. And to the left, it goes low, so we go high. And on the left side then, towards the left, our original gets very big, so our new is going to get small. And then our original gets very small towards the asymptote, so then we're going to get very, very big. The reason I want to bring this one up is it looks totally different than our last graph, where it actually crossed the x-axis. So just be aware, these can look different depending whether it crosses or not. And it may not have any asymptotes if it doesn't cross at all. Here we've got 2 asymptotes occurring, so we'll just happening at the x-axis or x-intercepts. So this one looks like it's at x equals -4, and this one's at x equals 2. Next is my invariant points. So I've got a height of 1 here, and a height of 1 here, or -1. Here it actually never gets to 1, so we wouldn't have an invariant point there then. We would have a reciprocated function though, so it's important to look. It appears this is our our vertex right here. It looks like it's at 1/2. So if we go 1 over 1/2, we're going to get 2. Meaning this graph is going to be all the way up here is going to be my bottom of this. Because as I go to the right here, it's going to get bigger and bigger. Because our original gets bigger as it approaches, smaller. Our original gets smaller as it approaches the asymptote, so our reciprocal is going to get bigger and bigger. Same thing is going to happen here as well. Now from these 2 invariant points, these are more similar to our other ones. So here, our original is getting very big, and to the right, our original is getting very small. Here from our left, original is getting small, so we go big, and then our original gets big, so we go small. Okay, one more left. To the right, or C, so we've got some asymptotes at the x-intercepts. And so that one occurs at x equals 4. And our last one occurs at x equals 8. One more time, we're looking for invariant points at a height of 1 or -1. So right there and there. And we've got 2 more at -1. Now here we've got a vertex, so that's at 2. So it's going to be 1 over 2 is our new height then. So it's just barely going to go up. And then from this right invariant point, our original gets very, very small. So we're going to get very, very big. Same thing is going to happen on the left side of this. Now from our right invariant point, that's +1. To the right, our original gets very big. So we're going to get very small. And to our left, we're going to get very big. And on our left one, it's very similar. We've done these again and again already. So that's our last 20-1 question. Let's move on to some 30 stuff.